Right, I'd like to get started, please. So today we start out with chapter 4, which is the beginning of trig, and it goes on for 3 chapters, okay, 4, 5, and 6. Okay, 4, 5, and 6. So what you see here are the topics, or some of the topics that we cover in chapter 4. So if you take a look at it, it's pretty extensive, okay, pretty expensive. And then chapter 5 builds on that, and chapter 6 builds even more on that. And if I were to tell you which are the most important chapters for calculus, I'd say it's 4, 5, and 6. So you really, I mean, all we've done so far, chapters 1, 2, 3, okay, that's algebra 2. Okay, so clearly that should be basic knowledge, okay. 4, 5, and 6 really extend the trig that you learned in algebra 2. To a level that you're definitely going to need in calculus. Okay, you're going to need in calculus. Do you guys want to take this down, or is that, I mean, it's just telling you what a summary now? You good? You want it down, Emma? You want to take it down? You did? Ooh, that was pretty fast. Okay, so what we're going to do is talk about, first of all, how you did use angles in geometry. Okay. In geometry, the angles are always in some sort of a triangle or some figure, okay? A pentagon or a hexagon or whatever, okay? And they are typically less than 180 degrees, and they are always positive, okay, in geometry. Well, in pre-calc, we throw all those things away. They don't have to be less than 180. They don't have to be positive. Okay, you could get an angle of minus 720 degrees. Yeah. Yeah, I think I told you this yesterday. 4.2 is when we're going to do it the other way. So in pre-calc, there's a whole different convention of how we do angles. Okay, and that's the convention. So I'll pause here for a minute and let's. So from geometry, you know that angles are formed by 2 lines. Okay, you're formed by 2 lines. So in pre-calc, the initial side of the angle is always on the positive x-axis. So here's your initial side. Okay, on the positive x-axis. And then you've got a terminal side that in this particular case looks like this. Okay. So if you measure the angle in the counterclockwise direction, then it's denoted as positive. Okay? If you do it in the clockwise fashion, then it is negative. Okay? The other concept you need to know about angles in pre-calc is that angles on the terminal side end up in one of 4 quadrants. Quadrants 1, 2, 3, and 4. Labeled as such. Okay? So if I were to kind of estimate, I'd say, oh, the blue angle looks like 120 degrees. Notice that if it's positive, you don't necessarily say plus. It is understood that it's positive. Okay, just as when you write the number 1, it's understood it's positive. Okay. If you were to look at the angle measured in the clockwise direction, which would be going this way, then that would be negative 240 degrees. I'm just kind of guessing at that. All right, so do you guys get the convention? Positive, negative, okay? Doesn't have to be necessarily less than 180, okay, unlike in geometry. Okay, so that's the convention. Okay, let's do some SAT analogy stuff. Celsius is to Fahrenheit as degrees is to? Nice, good job. So can you make a conclusion out of that? Can you give me a conclusive statement out of that analogy? What can you say about degrees and radians? What are they? Okay, let's go back to this. What can you say about degrees Celsius and degrees Fahrenheit? What can you say about that? They measure temperature. What can you say about degrees and radians? Thank you. They measure angles. Okay? You guys get that? So there's nothing magic about radians, okay? A radian doesn't have to have pi in it. Okay, that's the common myth that high school students have, is that if they have a pi, then it is understood that it's radians. Not necessarily. I mean, I could do something like this to you, and you guys know that I'm pretty nasty, and I can do something like this to you. Well, that's pi degrees, 3.1412 degrees. Oh, whoa, how many digits do you know? 6 digits? 6 decimal? 3.141? 59? That's a random. He's just random. He's just BSing. Okay? Alright, you guys get the point. That when someone tells you that there's a radian, it doesn't mean that it's going to show up with a pi in it. For example, I can tell you that an angle is 1 radian. Okay? And you guys know how you differentiate between a radians and a degree. Right? If you have a degree symbol, then it's a degree. If you don't have a degree symbol, then it's a radian. Okay? You guys alright on that? What the hell is a radian? Okay, we'll get to that in a minute. So just like you've had formulas in chemistry back in 6th grade to go from Fahrenheit and Celsius and vice versa, right? C equals 5 9 F minus 32. Oh my God. I got to teach you physics, I got to teach you chemistry, I got to teach you non-bullshitting, I got to teach you not to smoke. Man, the pressures you guys put on me, the things I got to do for you. Okay? So just as you have formulas that take you from centigrade to Fahrenheit and vice versa, while you got formulas that take you from degrees to radians and back and forth. You with me on that? Got it? I'm not. I'm just slicing this up so I can work on it. Okay, so the red box is to go from degrees to radians, the blue box from radians to degrees. Okay, so if I want to go 30 degrees to radians, this is what I would do. I would go 30 times pi over 180, which is pi over 6. Okay, so if there is no degree symbol, it is understood to be radians. Okay, no degree symbol means it's radians. And if I want to go from pi over 4 radians to degrees, I will go pi over 4 times 180 over pi, and that gives me 45 degrees. You guys with me on that? Why? Nate? What's so? Nothing at all? You don't want to share any jokes with us? I'm good. You good? I don't know if you, what about the rest of the class? They like funny stuff. They like funny stuff. Nothing funny to say? Well, then I've got some relationships for you. Okay? It's not just Justin Bieber stuff, okay? It's not Justin Bieber relationship, okay? This you've got to know more than Justin Bieber. Who's he, by the way, anyway? That little twerp, he looks like 12, but he's 20. That's him. But he's growing a mustache now. Did you see that? He's growing a mustache. Yeah! Yeah, I just saw that. Okay? So, Miriam, do you know how relationships, you take them to heart? They're really sacred and important. These are just as important, if not more. Like your relationship between you and Zara is second rate compared to this. Second rate compared to this. What? No. I'm saying this love is higher than that love. Okay, you guys done yet? Come on, Zara. Yes? Oh. Well, then you're going to watch YouTubes and then take it. Okay, coterminal angles. All right, listen up, people. So, concept of coterminal angles, okay? Coterminal angles are two angles that have the same terminal side. Clearly, the initial side is always the same because it's the positive x-axis. Nice, okay? Positive x-axis. So, for coterminal angles, like if you see in this picture here, okay? You've got 120 degrees being coterminal with minus 240 degrees. Right? Gives you the same terminal side. You end in the same place. Eric, you're not too happy? You happy?
Wait, so if you're in the number 2 and you started out like you're always coterminal.
Huh?
Like if you never mind.
So if you go, remember, if you're measuring angles in with a positive direction, that's going to be counterclockwise. So if you go this way here, okay, that's 120 degrees, and this is your terminal side. And if you're negative, you're going to go clockwise, and you're going to go this way, and you end up at the same place, same terminal side.
Okay.
You with me?
Okay.
Yes, kinda, sort of, maybe.
So
All right?
It's the blue line, the terminal side.
No kidding.
Got it.
All right? Okay, so let's find two angles. So I'll find one for you, and then you do the other one for me. Okay? Find two angles that are coterminal with 3 pi over 5. One of them positive, one negative. Okay? So one positive, one negative. So the first thing you want to do is you want to draw what this angle is going to be. Okay? 3 pi over 5. So that'd be about 108. About 108 degrees. So somewhere out here. Okay? Now, is this angle in radians or is this in degrees? It's in radians. Yes? Oh, 3 pi over 5 times 180 over pi. You got to know your conversion. Okay? You got to know how to convert. Okay? All right, so I'll give you another one, positive. So here it is. I'm going to go 2 pi, and then I'm going to go that much more. So anytime you add 2 pi to an angle, it'll either 2 pi or 360, depending on whether you're in degrees or radians, you'll always get the same angle. In other words, it'll be coterminal. So this would be 13 pi over 5. You guys with me on that? Okay, listen up. Okay, you always start from the terminal side. Okay, and since I'm going to give you the positive one. So if you're going to go positive, what direction? Clockwise or counter? Counter. So here it is. That's your counterclockwise direction. You came around in full circle, didn't you, right now? That's 2 pi. And then you add 3 pi over 5 to come back to the same blue line. Guys with me on that? So 2 pi plus 3 pi over 5 is 13 pi over 5. So this is coterminal with this. In other words, they're the same terminal side. Are you guys with me on this? Sorry? No, listen up, Ray. I said that I want two answers, and I gave you the positive one because that's easy. You give me the negative one. Yeah. Sorry? You got to give me negative answer, dude. Negative 7 pi over 5, is that what you're saying? Or are you saying 7 pi over 5? Negative 7 pi over 5, yes.